Okay, 5.3. Most of this is a review section. So we're going to start off review, but I'm going to show you two different formats, how to add and subtract polynomials. What does the word vertical mean? Up and down. Okay, so in letter A, you guys look at this new color I got. Ooh, my color wheel came on and I was like, I don't know how I did it, but then we changed the color. It was really neat. Vertical means you're going to line them up where you line up like terms and then add them in vertical columns. So if you like this method, then every time you see them, line them up vertically and add them. I personally don't like it, but if it works for you, terrific. Be careful that if you have an x cubed, it's understood to be a 1x cubed. And if you need to put the 1, put the 1. Okay, now horizontal. And sometimes I wonder if when I have a preference, it's the way that, like when I was in high school, did my high school math teacher do it that way? And so it's just how I know to do it. But I'm very flexible. Here's horizontal going across, whichever way you like. I do not care. You want to use the method that makes the most sense to you. Now I'm going to pause here. Our textbook doesn't talk about this, but it's actually a very, very important concept. Is we have something called essential parentheses and non-essential parentheses. And our book never talks about it, but it's sort of like assumed, so I think I need to be very direct here, is these parentheses, if I remove them, I'm going to get the exact same thing I had. So both sets of these parentheses are referred to as non-essential. I can take them or leave them, and I'm going to get the same thing. When you subtract, and you have the polynomial in a parenthesis, those are essential, because if I remove them, I don't get the same thing as when I had them in there. And you have to use the distributive property. But again, these are called non-essential parentheses. They're not important, okay? Now, I told you guys that, I do some tutoring, and I don't know if it's my student's teacher who taught her this or what. But what she does is she will look for like terms, and then she does this. Now, there's only a 3y cubed, so she won't do it with that. But she does this. She puts an underline under the like terms and goes negative 2y squared plus a negative 4y squared is minus 6y squared. And then watch what she does. And I just thought, well, I'm going to share this, and if it works for you, great. If you don't need it, great. It doesn't matter. I'm just giving some options here. This is a minus 7y plus 2y. So it's minus 5y, and the last thing left is minus 5. So if that helps you, great. Yeah?
So, sometimes in the book they'll tell us to do like horizontal or vertical. Is it okay to do vertical on horizontal if that's how you want to do it, or do you still want us to do it the two separate ways?
Do it the two separate ways so you kind of get comfortable. But like on a quiz, on the next quiz, I am not going to say do it vertically or horizontally. But if the set of directions say to do that, then do it. And they're just trying to get you comfortable with each to figure out which one really is your preference to practice enough. Okay, now subtraction. Notice this doesn't say which way to go, so you can choose your method. But this says subtract from the 8x cubed. So I need to point out to you that if you're going to subtract it from the second one had to be first. Now the other thing is, I need you to notice that if I'm subtracting a big huge polynomial, in order to subtract it, you have to subtract the whole part of it. So now let's go back to what I mentioned about essential and non-essential parentheses. If I remove the first set of parentheses, does that matter? No. So this first set of parentheses is non-essential. So I just drop them. However, my second set of parentheses is essential. Because if I remove them right now and just copy it as I see it, that would be wrong. I need to distribute the subtraction sign. So this actually becomes minus 3x cubed minus 2x squared plus x minus 7, like that. Yeah.
Do you have to take away the parentheses?
You do not, as long as you are very careful in mentally distributing. Okay. You do not have to do that, but I would strongly recommend that you do. Okay, so now watch what I'm going to do if I use that like term technique. This is 8x cubed minus 3x cubed is 5x cubed. Then I get negative x squared minus 2x squared, which is minus 3x squared. And then I'm going to get minus 5x plus x, which is minus 4x. And then 1 minus 7 is a minus 6. Okay? All right, I'm going to give you a head start on letter B. And see if you remember how to do this. All right, check it with the board. Did you get negative z squared plus 10z minus 15? Okay, super. Something I want to point out is this is all Algebra 1 review, okay? This is not Algebra 2 yet. So we're just making sure we have a solid foundation before we're going to get to our Algebra 2 stuff. All right, in example 3, now we're going to move to multiplying. And I'm going to be taking a trinomial times a binomial. And how you do this is you use what's referred to as the extended distributive property. You take everything in the first parenthesis times y, so that's negative 2y cubed plus 3y squared minus 6y. Then I take everything in the trinomial times a minus 2. So that becomes a plus 4y squared minus 6y plus 12. Now let's collect like terms. I personally don't do the underline thing, but if that's going to work for you, please use it. Now something I want you to look at is my 6y's. Do they cancel?
No.
Why? Why don't they cancel? They're both negative. What would I need to make them cancel? One is a negative and one is a positive. So I just want to point that out, okay? All right, negative 2y cubed plus 7y squared minus 12y plus 12. Now I want to pause here a moment before we go to letter B. And my experience has been that I've had students who get mixed up with how to multiply and when you're adding, okay? And so let me just take a quick moment to try to clarify that before we move any further. If I have 2x squared plus 3x squared, do you see that you have a GCF of an x squared? So that's actually giving you 5 times the x squared. That's why you don't make it 5x to the 4th. I get students who get mixed up as they want to try to multiply their exponents. Versus, if I take 2x squared times, that's a times, 3x squared, now that's 2 times 3 and then x squared times x squared is x to the 4th. Do you see the difference between, because now we're combining, multiplying them, and then adding like terms. Okay? All right, try letter B on your own. What you should do is take everything in the trinomial times x, everything in the trinomial times 3. Okay, so this is 3x cubed plus 7x squared minus 2x plus 12. Do you guys remember this from Algebra 1? Again, we're still in Algebra 1. Okay, all right, now in the next one, in example 4, I want to point something out to you. Let's go back to, elementary school. If you had been given a problem of 2 times 3 times 5, you cannot multiply all three numbers at the same time. What you can do is you can use that associative property and say, okay, I can figure out 2 times 3, that's 6, times 5, and that's 30, okay? Well, the same thing is going to apply now with algebra. I can group the first two together and multiply it out with FOIL, like I can do that. And something I want to point out that I want to make sure we're transitioning from Algebra 1 level to Algebra 2 level is when you FOIL it, we should not have to write out all 4 terms at this point. We should be able to do 1x minus 5x is minus 4x. Okay, that means you're ready for Algebra 2 to be able to mentally do your outer inner. Now, having said that, if you are getting them wrong, trying to do them in your head, then you do all 4 steps. You do what's best for you, okay? If it's just not working for you, it's just going to take you an extra line, and that's what we're trying to get away from. Okay, now, do you see how this problem is like example 3, A and B? There you go. All right, so now let's use the extended distributive property. X cubed minus 4x squared minus 5x. Then I'm going to take everything in the trinomial times 3. 3x squared minus 12x minus 15. Now you guys know that I love math, but I have to tell you that multiplying trinomials times binomials and trinomials times trinomials, it floats my boat. I think it is so fun to do these. Like, I could literally do these all day long and be so happy doing these. I don't know what it is about them, but I just think it is super fun. Oh my gosh, like, I don't know what it is. And especially when you do a trinomial times a trinomial, there's all those terms and you're trying to collect them all and make sure you're doing them right. I'm like, wow, for me, that is a good time. And I know it's weird, but okay. Now, I need you guys, we're going to step off of our notes for a little bit, and I need you to find a clean sheet of paper, okay? I need you to find a clean sheet of paper. And we are going to try to explore before I just give you a list of properties, okay? So we're stepping off of our notes a moment. You need a clean sheet of paper. And I want you to multiply all 5 of these out using FOIL, okay? And then I want to see if you can figure out the pattern. Yes, Noah.
Can I see if I got the pattern?
Yeah, what do you think it is?
It's like x squared minus 25, and like, it's like you just square each number.
Okay, and then the outer inner are canceling,
Yeah.
right? Okay.
It's a difference of 2 squares.
Yes, it's also
Yep, that too.
the difference of 2 squares.
You just make me like that.
You explained it.
Have to say it.
All right, so in number 1, you got x squared minus 25. In 2, you got x squared minus 16. Then you got 4x squared minus 1. 25x squared minus 9. 25x squared minus 36. So if they're the same numbers, but one's a plus and one's a minus, It causes the outer and inner to cancel, and it's called a difference of two squares. Okay. Now, I want you to try this group, okay? And I do need to remind you that x plus 5 squared is not x squared plus 5 squared. It means x plus 5 times x plus 5, and you FOIL it. So go ahead and do that with each of these. Yeah. You think you've got the pattern already?
Yeah.
Okay, what's the pattern?
It's like the same thing except in the middle you just add them, like 5 plus 5,
Yeah.
and add the x's.
Okay, so here was the point. I was hoping that before you got to the fifth one, you would notice the pattern. And again, I didn't want to come out and tell you. I wanted you to figure it out. Is that here's the shortcut. You take x and you square it. You take the 4 and the square it. But then notice it's really x times 5 because you're getting a 5x and a 5x. You're getting 2 of them, right? So this would be 4x, but I have 2 of them, so it's 8x without trying to FOIL it anymore. So then this one's going to be x squared, and then how many 8x's? I have 2 sets of them. So it's x squared plus 16x plus 64. Okay, now here's where it could get tricky, all right? Because I'm getting 4x squared and I'm getting a 9, but if you think about it, what ends up happening is you're taking the 2x times the 3, and you have 2 of them. So I have 2 of the 6x's, so it's a 12x, like that. So then here's, I can do it, that's 25x squared. 5x times 6 is 30x, but I double it. Do you guys see that? That's a pattern that we have. All right, now, we have something called Pascal's triangle, and this is super cool. This is not quite in this section, but I wanted to show it to you, because we're going to do it later in our year, but it's really helpful. I feel like in years past, I haven't done it, and I felt like a cheater, because I knew it, and you guys were doing things the long way. All right, so here's the pattern, okay? You start with 1, and until you get the first 2 rows, you start with a 1, and then you add the 2 previous numbers, and then you end in a 1. So you begin with a 1, then you take 1 plus 2 is 3, 2 plus 1 is 3, and you end in a 1. You begin with a 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and you end in a 1. What would be the next row? 1, 5, 10, 10, 5, 1. Okay, what's the next row? 1, 6, 15, 20. Okay, now, you can do this for a really long time, but here's the cool connection to what we're doing. And this is like, to me, mind-boggling that they came up with this kind of stuff when they did. If you look at binomials, which we've been looking at, squaring them, and now we're going to look at cubing them. This is really the point. But if I look at a binomial, x plus y to the 0 power, that's 1, right? And if I take x plus y to the first power, isn't that 1x plus 1y? Oh my goodness, watch this. All right, Elena's light bulbs are flashing. Here we go. Watch. This is 1x squared plus 2xy plus 1y squared. Watch this. This is 1x cubed plus 3x squared y plus 3xy squared plus 1y cubed. Instead, look at her, she's like, Instead of doing x plus y times x plus y times x plus y and doing all that work to group the first two, then do the trinomial times the binomial, and then collect all your like terms, it actually is equal to this. Now let's go one more. I mean, I feel like a cheater when kids are having to multiply it all the way out. I'm like, I don't multiply all that out. I use my Pascal's triangle. This would be 1x to the fourth plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus 1y to the fourth. Now, you guys following the pattern, it starts with x to that power, but there's no y. And then the x's go down, and then the y's are coming up, okay, the other way. So, having said that, now go back to your notes. Now leave this paper nearby because we'll come back to it. But here's your sum and difference. A plus b times a minus b is a squared minus b squared. So if I have x plus 4 times x minus 4, it's x squared minus 16. Excuse me. Okay, squares of a binomial, we just reviewed that. If I have a plus b, the quantity squared, that's a squared plus 2ab plus b squared. So that's like y plus 3, the quantity squared, would be y squared plus 6y plus 9. Now if I have a difference, the only thing that changes is that the middle term is a minus. Now, I'm going to do a little bit more difficult of an example here, okay? If I gave you 3z squared minus 5, and you're squaring that first term, what's 3z squared being squared? 9z to the fourth, right? So that's 9z to the fourth. You would take and you multiply these, so that's 15z squared, and you double it. So it's minus 30z squared plus 25. Okay, now here comes the cube of a binomial. And we're going to be using Pascal's triangle. Your textbook just says memorize it. Well, now, if we understand, and you can create the Pascal's triangle, you know, like 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, and then you have it. You're right there. So it's going to go 1a cubed plus 3a squared b plus 3ab squared plus 1b cubed. Now, of course, we don't really put the ones, but do you see how the ones are helpful to see the 1, 3, 3, 1? Now let's look at an example. If I say that I have x plus 2 cubed, a is the x and b is the 2. Do you guys understand that? That a is whatever's in the first position and b is what's in the second position. So I'm going to go 1 and then it's x cubed plus 3x squared times 2 to the first plus 3 times x to the first times 2 squared plus 1 times 2 cubed. And then we're just going to tidy this up. So this is x cubed plus 6x squared. Now what's 2 squared? 4. 4 times 3 would be 12. And 2 cubed is 8. Now, the only thing that's different is when you subtract, it just makes the signs alternate. Okay, so an example would be, what if I have y minus 3, the quantity cubed? Okay, if I have y minus 3, the quantity cubed, it's going to be 1 times the y cubed, and then all you have to do is the signs will alternate. But you're not going to put a negative 3 in. You're going to put a 3 if we just make the signs alternate. So it's minus 3y is being squared times 3 to the first. Let me say that again. You're not making b negative 3. You're making the signs alternate, and that takes care of the minus sign, okay? Plus 3 times y to the first, 3 squared, minus 1 times 3 cubed. So I'm getting y cubed minus 9y squared. Now be careful here. 3 squared is 9. 9 times 3 is 27. And then 3 cubed is 27. Alright, because of time, we're going to skip example 5A and B, and we're going to jump to C, and then try to do another example if we can. Okay? So let me show you how this works. So we're going to do just C. I'm going to do 1 times 7x being cubed plus 3 times 7x being squared, 2 to the first, plus 3 times 7x to the first, 2 to the second, plus 1 times 2 to the third. Alright, I do not expect you to know 7 cubed in your head. You may use your calculator for that. So 343x cubed plus, now this is going to require a little bit more work than the other two that I did with you, because I need to figure out 7x being squared is 49x squared. Okay, so do you see that? I'm just going to make it 3 times 49x squared times 2. Then that's 3 times 7x times 4 plus the 8. Now you might need your calculator there. 343x cubed.
138, sorry.
I got 294
For 49 times 3.
times 2. There's also a 2.
Oh, okay.
Did you lose
Yeah.
your 2 there? Yeah,
Yeah.
okay. Yeah, there's a 2. Plus 84x plus 8. Okay, so now what I want you to do is, we're not going to do those last 2 word problems, but I want you to just put an extra example there. Let's expand 5x plus 3, the quantity cubed. I'm going to give you a head start on me. And I want to see if this is starting to connect. This one was the first Algebra 2 thing that we did. The first and only Algebra 2 thing in the section, okay? The rest of it was all review of Algebra 1. So it's nice, we lay a nice review foundation before we go into the more difficult stuff. However, I need to mention, if any of that Algebra 1 review you were completely lost, that means you need to come in at lunch during math study table. I am more than happy to reteach and go over it in a more concrete way with you, but there's an expectation you learned your Algebra 1, okay? Alright, check yours with mine. 125x cubed plus 225x squared plus 135x plus 27. You guys get it?